everyone, and welcome to the VMware 2021 NSX-T Fundamentals Guided Workshop recording. So for this recording, we're going to go over HOL 222501, and that's the NSX-T Fundamentals. And here's the agenda for our session today. We'll be doing a brief introduction of the HOL team, how we constructed the lab topology, and then we'll have a couple of different instructor guided lab sessions. So first off, I'm Jen Schmidt. I am a staff virtual cloud network TAM. I have been with VMware for 6 years now and also part of the hands-on labs program for 5 years.
Claire, I'm a network and security solutions engineer based in France. And I've been at VMware for 4 years now and 3 years in the hands-on lab team.
Great, thanks, Claire. So also part of the team, we have Joe. He is 6.5 years at VMworld and has been with our labs for 4 years, and we've been working together on these NSX labs for quite some time. We also have Phoebe, who's been with us for about 2 years now, and Mickey, who's been with VMware for 4 years, and this is his 3rd year working in the labs. So that's the team of 5 of us that have been constructing all these 2225 labs, and it definitely takes a team to get this stuff put together. So speaking of putting the labs together, we kind of just want to do a brief overview of how we construct the lab. The lab design process is kind of like any other process of a project that you may work on. The first thing that we really start out with is our storyboard. So our storyboard is a grouping of ideas that the lab captains, along with the respective business units, kind of build out and put to paper what they want to see and showcase in the lab for the year. After we have that storyboard, then really comes a lot of the hard work. And we start building out the pods and the manuals to go along with that. So this lab is HOL 2225. We have 3 different manuals. So the 01, the 02, and the 03 manuals for this one pod. So basically, in this sense, we had to start with a base template of the pod that our HOL core team creates every year. And from there, we build out. This year, we used a multi-site base pod for a region A and a region B construction in our base pod. And then with that, our team went through and started building out the different manuals and showcasing different features of NSX with those manuals. And then, of course, with any process, we have lots of testing. We have we have our beta testing, our functional testing, and then our pre-release testings. So we get a lot of people involved to test out our labs to make sure that, one, our manuals read well, they don't have any errors in it, the screen steps, all of the steps that we capture to follow along make sense. And then after that, we can finally release it and showcase it to the world. So brief overview of the 222501 lab. We have 7 modules in the NSX-T Networking Fundamentals lab. As you can see here, we've got introduction segments. We talk about NSX segments, routing, NAT, distributed firewall, and the gateway firewall. However, for this 60-minute workshop, we're going to just do a brief overview of modules 1 and 2. I'll do a quick walkthrough of some of the NSX components, the managers, the transport nodes and edge nodes. And then Claire will go on to kind of walk you through modules 3 and modules 4. Module 3 is on NSX segments. And then in modules 4, we will just only be going over the east-west and north-south routing components. So the lab topology, as I mentioned before, our lab has 2 regions. For this lab, we are specifically only using region A. And in our region A vCenter and NSX manager, we are composing that. We have the 4 ESXi hosts. Two of our hosts, ESXi01A and 02A, are in our compute cluster, and that's where our 3-tier app VMs are going to live. And then for our Region A edge cluster, we've got ESXi03A and 04A, and that's where we have our edge node VMs. These edge node VMs have already been deployed for you, so we have 4 of them in there. This lab right here that we're going to walk through will focus on edge cluster 01, which has edge node 01A and 02A composed in it. If you go through the lab in full, you will go through the creation of creating this second edge cluster here, but that is not something that we're going to showcase in this guided workshop today. So for our lab topology and for the sake of the guided workshop today, this is kind of the setup that we're starting with. We have our admin desktop, which we'll log into, and that connects directly to our vPod router. Our vPod router is part of that base template that I talked about. That's something that our HOL team deploys for us as part of that base package. And then for our NSX workshops, we have to kind of manipulate the base pod vPod routers a little bit to get some of the NSX-T stuff working the way we need to. However, when the lab starts out, we already have a pre-configured T0 gateway, and connected to that T0 gateway, we have our web logical switch and our app logical switch. When I turn it over to Claire, she's going to walk through how we create this DB logical switch and connect it to the T0 router. And then from there, she'll go on to some more advanced routing features. So now I'm going to take you through a walkthrough of the NSX managers and the transport and edge nodes. So before we get started, I've already logged into my hands-on lab environment. Just a few quick little features here. Sometimes the screen on the hands-on labs can get a little small. So you have the ability to move the desktop screen anywhere you want. You can hide and move around the manual screen here. You can close it all together. You can move it over to the left side. You can kind of play around with it as you wish. One other thing I want to point out here is the table of contents. So if you were to just come in and want to say take a specific section of our lab, you can most certainly do that. Here's the table of contents. You can click on the arrows here to kind of guide you to see what is in each module. And some modules, like the NSX routing, have different segments in it. So we've got our logical routing, east-west, our north-south, the high availability, and ECMP. So you can kind of go through here and see what maybe you want to take. Now, most of the lab you can take in in an out of order sequence. However, if you are to do that, please make sure that you go to the overview and make sure that you run the certain scripts that need to be run before you skip around. Because let's say if you wanted to start with the logical routing, you need to make sure that this logical switch is connected to the T1 that we have in this diagram here, and that all the current steps that you maybe had to do if you had gone through the lab in whole have been completed for you. So here you'll see, notice to users before taking module 4. It just runs you through how to run some of these Postman scripts that we've created for you, so that way you can just jump right into any module you would like. All right, with that said, I'm going to head over to the lab. So always check that your lab status here is showing a lab status of ready in green, and that means all the components have been tested to be up and working as they should. So I'm going to go ahead and open Google Chrome. And as I said before, we have the 2 regions. I'm going to focus here on region A and go to the NSX manager in region A. Now, if you ever need a password for anything, if the instructions are telling you to log in somewhere, You will most likely have the instructions there on how to log in. Otherwise, if you need a quick reference, you can go to this README file on the desktop, and you'll have all of your logins, your usernames and passwords for everything that you need. And also, as an added bonus, we've gone ahead and saved the NSX-T and vCenter logins for you. All right, so as we go into the NSX-T console here, I'm going to go over to System and Appliances. So here you see we have one NSX Manager appliance. The reason why we only have one is because this is a cloud lab environment. So we do want to make sure that we are utilizing the resources correctly. As some of you may know, the NSX-T Manager kind of takes a heavy footprint to deploy. So in a lab setting, we can deploy just one NSX Manager. We just have no redundancy. However, be aware that in production, you should always deploy a 3-node cluster. So then under System, I'm going to go here to Fabric, and we're going to take a look at the nodes. These nodes have already been configured for you. And please note that anytime going through your lab, you can use all of the column arrows here to expand anything that you need. So we've got our edge cluster here, which are just hosting our edge nodes. Therefore, they are not configured for NSX-T with the VIBs. However, your ESXi 01A and 02A in your compute cluster are already configured for you. So you see you have your NSX configuration status as up. We have a host switch configured, and we are using vSphere 7. So we have configured these to use the VDS in vCenter. So along with that, we have our edge transport nodes. And as I mentioned before, we've got 4 of them. 2 of them, the first 2 are in edge cluster 01A, and that is where we're going to use the bulk of our lab configurations. We've got the 2 nodes in there. And if I go ahead and click Edit, you'll see the configuration for the cluster. So as I go back to the edge transport nodes, you'll see that we are configured here for an overlay transport zone and a VLAN transport zone. And we currently have one logical router on there, which is the T0 gateway that we have pre-configured for you. And just a quick look into the configuration of the edge node. As I mentioned before, we've got the overlay and the VLAN transport nodes. We have our edge uplink profile that we have already defined in our profile section. We are using an IP pool to create the edge nodes, and we've predefined a region A TEP pool that the IPs for the edge TEPs are coming from. And here you'll see we have our edge uplinks, uplink 1 and uplink 2, and they are mapped to these trunk ports on the distributed virtual switch in vCenter. So we've gone ahead and created 2 trunk ports, port groups on our VDS and attached these there. That way we can allow all VLANs through our TEP VLANs and our BGP routing VLANs. Then just a quick little look at the transport zones. We do have our defaults here, but we did go ahead and create the overlay and the VLAN transport zone for our purposes. So with that said, I'm actually going to hand it over now to Claire, and she is going to go through the NSX segments and routing portion. All right, Claire, all yours.
Yes. Thank you, Jen. Let's share. So right now I'm on the same hands-on labs platform, as was Jen just before. And so once we've done the explanation of the different components, I might go through, I might be going through the module 3 and 4, as Jen was saying before. We'll be going through creating segments and routing, that is to say, layer 2 virtual constructs and layer 3 virtual constructs in NSX. So let's go. So for the logical switching, what is a logical switch? What is a segment? We also call it segment. It's a layer 2 construct. So it's a layer 2 overlay network that will provide isolated broadcast domain. So as you can see, we already have an app logical switch, a web logical switch, and the idea of the module 3 will be to create this database logical switch and to attach a VM to it. So our database VM, which is already there in the environment. So I go through the creation of the segments. So you go into the networking tab, segments, and you click on add segment. Then you enter the segment name. You can use the send text icon right on the top left hand of the screen to help you write down the different informations. So database logical switch, we connect it to a gateway, so a router, a virtual router, the tier 0 gateway, which is already there in the environment, already configured, as said Jen before. And we attach it to a transport zone. So as Jen said, we created the overlay transport zone and VLAN transport zone. So the layer 2 broadcast domains in NSX will be using those transport zones. Okay, they are created as part of those transport zones. So a transport zone controls which hosts a segment can reach. So this means if 2 hosts are on the same transport zone, VMs that are hosted on those hosts will be able to be attached to the same segments and will be able to have connectivity. So that's an object that is created to for this purpose. Then you set up the subnets, the IP address and subnets. So this will be this subnet created with the attachments to the tier 0, with the interface attachment to the tier 0. You save, and you, oh, sorry, I might have created something. I'm going to write it again. Nice here. And just save. And we don't want to continue configuring this segment. So we click no. And so we see our database logical switch has been created. So now we will connect our database VM to this logical switch. So let's go to our vCenter. So if you don't arrive on this screen, if you don't, if the screen does not appear when you enter the center environment, you can go through the host and clusters here under menu to give you the inventory of the different VMs we have got in the environment. And we're searching for the database one. So we will edit setting of the database attach it to the right environment, to the right logical switch. So let's browse another network adapter, and here, as you will be able to see, you have app logical switch, database logical switch, and web logical switch, which are here, which come here, appear here. So the idea is to be able to take the database one, change network adapter to attach this database to this logical switch right now. And also you can see the IP address of our database, which is in the same subnet as what we created for the logical switch. So now that we have attached this VM, I might show you the different segment profiles we've got. So a segment profile is a configuration template that can be attached to apply to a segment port or a segment as a whole. And you've got several profiles already pre-configured. So that's available here in the segment profiles tab. So now that we have seen how to configure layer 2 virtual constructs, we may want to be able to settle some connectivity between the different web, app, and database logical switch. Okay, so right now we've got connectivity because the tier 0 is already configured, but we will be in the module 4 creating EastWest connectivity, instantiating what we call a tier 1 router, so another layer of routing, and enabling east-west connectivity and north-south connectivity. So that's why in module 4, NSX routing, you've got different sub-modules with logical routing for east-west traffic, logical routing for north-south traffic, and we'll be going through the east-west and the north-south one. So let me find, we shall have a logical topology here. So we're going from a tier 0 and web and app and database connecting to this tier 0 to a topology where we will have another layer, a tier 1 router, and those logical switch attached to it. So NSX, as you can see, includes two types of gateways. Okay, tier 0 and tier 1. You can see them here also, two types of tier gateways. And NSX deployment will typically consist of at least one tier 0 gateway that includes uplink connections to the physical network. Okay, this lab has been pre-configured with this tier 0, and a tier 0 gateway can provide routing to multiple tier 1 gateways, allowing multiple isolated tenant environments. So that's what we will be doing. We will be creating a tier 1 gateway. So the tier 1 will be created here in the tab tier 1 gateways. You add another tier 1 gateway. So for my part, yes, I'm sending text here because it's easier for me as I sit in France and I have a foreign keyboard, I'd say, but you can use also the keyboard to enter directly the different text in the text fields. So Tier 1 gateway. We select an attachment to this tier 1 gateway, so the tier 0 gateway. And we will be also, so we can save, continue configuring this tier 1 gateway. We will be also configuring some route advertisements, because as we will be connecting our logical switches to this tier 1 gateway, we want the segments to be advertised to the tier 0 gateway and to the and for the tier 0 to redistribute those routes to the northbound routers. So we toggle to the right the all connected segments and service ports. We close editing. We can see that our tier 1 gateway has been created. For now, we have 0 linked segment to this tier 1 gateway. All the segments, all the logical switches are linked to the tier 0 gateway right now. So we need to be able to put those segments onto the tier 1 gateway. So to do this, we will edit the different segments and change the connected gateway to the tier 1. AS. And the database one. So as you can see here, we're all doing things, we do all the things in software. That's the idea of NSX, creating all in software. Changing this. And having this abstraction of those layer 2s, not having to go on the physical network to propagate those different subnets. And here you can see also for our database logical switch that it has discovered the VM, the database VM that we just added here as a segment port. So we just attached all our logical switches to the tier 1 gateways. So now normally you should have 3 linked segments to the tier 1 gateways, and here 0 linked segment to the tier 0, but still a linked tier 1 gateway. So now we have enabled east-west connectivity, so connectivity between our different logical segments that are reattached to those tier 1 gateways. So we can test this connectivity by going back to our vCenter. For example, on one of our web VMs, launching web console and trying from there to reach out to the different other segments or segment ports or the different interfaces of the tier 1 router. So let's dive into it. You have access, as Jen said in the manual, to all of the different logins and passwords, and also for some of them directly on the desk. So right now I'm on the Web01 AVM and we'll just test our east-west connectivity to the, let's see, for my part, I need to go through this. Oh. So for example, our our app VM is in 20.11. We could also ping directly the name of the VM. And we can see that we can access, I could do this for the other ones, for the database. We can see that we have access to those different VMs residing on different segments. So we have settled up the East-West connectivity right now. The idea will be then to set up the North-South one. So in NSX, we have an object, a concept called an edge node, which Jennifer talked about earlier, which will provide computational power and north-south routing services to the NSX fabric. So the edge nodes that Jennifer showed us in the fabric are appliances with pools of capacity that can host routing uplinks as well as non-distributed stateful services. And they can be clustered for scalability, higher availability, etc. We will review or just maybe go through it later, but just remember that when we talk about north-south connectivity, we will need to use those edges. The tier 0 gateway will use those centralized services on appliances to have access to the physical, the northbound routers, and peer with those northbound routers to redistribute the different routes that he has discovered. So as Jen showed us before, it is the edge nodes can be seen on the system and fabric side here. I will not show it again for now, but what can I say again is that we've seen with the logical switches that we use the transport zones, the overlay transport zones. For the edge ones, as Jen showed us just before, we will be using also the VLAN transport zone. So the difference between the two is that the VLAN transport zone is used by the edge to do this connection to the physical network fabric and to do this peering with the physical core. And the tier 0 gateway, when you create the tier 0 gateway, it will create an interface in this transport zone to pass traffic with the environment outside of NSX. And the overlay transport zone is used to connect the NSX overlay network and the communication with other host transport nodes and edges inside of the NSX fabric. So that's why the edge nodes has the two of them, because the tier 0 will be using it to send traffic through the different northbound routers. So let's review the configuration of the tier 0 gateway just for this northbound part. So we can go on networking tier 0 gateway on the left, expand the different informations around the tier 0 gateway. So for the interfaces here, we can click on the number to the right of external and service interfaces to have access to the different interfaces of the tier 0. And here we can see that we've got an uplink, one uplink with this IP address residing on this edge node right here. So that's an external uplink. And you can also review this with this IP here on the logical routing topology that we've got here. So this is the external uplink that we've got on the tier 0. On the tier 0, we can also look at the BGP configuration and the different BGP neighbors. So we've got this same BGP neighbors here that we can also see on directly on the topology, on the diagram, with a remote AS number and a status of up. So that's how you see the different informations on the tier 0. Let's enter in edit mode because we still have to do something to have access to the external world, is to redistribute routes, because we, as the tier 0 was already there, already configured by us when you enter in the hands-on lab platform, you have access also, you already have access to some redistribution routes. But as we added a new tier 1 gateway together, we still need to redistribute the routes that would be advertised by the tier 1 router. So we need to check the connected interfaces and segments for the tier 1 routers. Then you apply this configuration, you add it to the redistribution policy, the BGP redistribution policy. Here in our lab, we're using BGP, as you could see in the BGP neighbors and the BGP configuration. We can save the configuration and close editing again. The network topology can also be seen on the tab network topology in the menu on the left side. So we got a network topology that is represented depending on what you are configuring. Here we've got our tier 0, our tier 1, the different logical switches. So this is something that has been introduced with NSX-T 3.0, is this visualization of network topology. And this view displays this graphical representation of the different IP addresses and the different components. So here the tier 0 still has his uplink interface here. We've got an auto-configured subnet created between the tier 0 and the tier 1 when we created the tier 1. And this can also be changed if you want to change this IP addressing by yourself, but this is something that is auto-created when you create the plumbing between the tier 0 and the tier 1. Our logical switches, as you can see, have been connected to our tier 1 gateway. So this is for the logical topology. We can also verify our north-south connectivity by doing here a tracers. By doing here a tracer, so to the web LS. And we'll see again the same types of IP addresses to go to the web logical switch. So here we're testing the north-south connectivity. As you can see here we've got a request timed out. This is because of, this is the auto-configured subnet that we reviewed here. Okay. It is not advertised to the external network, therefore it is displayed as timed out in the root path. This is normal. And we can also test our north-south connectivity because as we have got this 3-tier sample up in our lab, We can test this this north-south connectivity by going directly onto the Web01 or Web02 VM and having access directly on directly to the web application by clicking on the bookmark on the toolbar here. So you can access it here. We access it via Web01, but we can also access it via Web02 if we want, and test the north-south connectivity this way in the lab. This is something that is used for a lot of our modules when we want to test the connectivity access to the application, when we want to test the distributed firewalling or the north-south firewalling. This is something that is commonly used in the manual to test access to your application, having clicking on this toolbar right here, on this bookmark, sorry, right here. Okay, so we're done with the north-south part, and I just hand it over to Jennifer to present you the different labs we worked on. So I stop sharing.
Okay, thanks, Claire. I want to go over that, along with our on-demand session, you will be able to access the entire lab, the 222501 and the rest of these after VMworld. So if you are watching this guided workshop during VMworld, you will not have the ability to follow along with Claire and I as we had guided you through the workshop and through the lab. However, after VMworld, this lab will be published, so you will have the ability to start up the lab yourself and follow along, the steps that we showed you throughout the lab while you are doing it yourself. So along with the HOL 222501 Networking Fundamentals Lab that we have put out, we've also put out the 222502, which is an NSX-T Advanced Networking. Here you'll find more information on advanced routing features like VRF and multicast. We've got a VPN in there. We have a great ISIM module on federation. So I know if anybody's interested in federation, definitely check that out. And we have also some NSX native operations in there. And with the 222503 lab, this is our NSX migration coordinator. We've got, our walkthrough on how to do a NSX V to T migration. We've also have some sub-modules in there that walk through just using the DFW module migrator, and also a great ISIM on how to migrate universal objects from NSX V to T. So definitely go ahead and check those out. They will be posted after VMworld. And that is all we have for you guys today. Hope you enjoyed this session and enjoy the rest of VMworld.